As trigonometric equations get more involved and complicated and creative, you're going to have to use methods that are outside the normal algebra and factoring techniques, right? U substitution alone is not going to do it anymore. So I have a list here of things you should try and a pretty good order you should try them in. Generally, if you find that factoring is not working, you should proceed to multi-angle identities, and then to Pythagorean identities, and then to quotients and reciprocal identities in that order, and that'll usually keep you out of trouble. So let's start with this one. And if you notice, as we're looking at this equation, I've got cosecant, cosecant, and then, yikes, cotangent. And that's going to prevent me from using any kind of factoring or normal algebra. So I'm going to go down my list. You can see there's no multi-angle identities, right? Everything is just a single phi in here. So there's no identities I can exploit there. We're going to use a Pythagorean identity. And if you remember, there's this thing called the cottage cheese identity. So 1 plus cotangent squared equals cosecant squared. Right? That's one of your fundamental starting points of Pythagorean identities. So let's put that in here. And what I'm going to do is rewrite this equation over here on the left. And instead of cotangent, I'm going to use my identity that I wrote there and write cosecant squared minus 1. Okay, otherwise everything stays the same. Negative 5 cosecant and plus 4 cosecant squared. Okay, so obviously there's some stuff that's going to simplify from this. Let's clean up some space here. And I'm going to distribute out. We're back down to normal algebra at this point. I see the only thing there is on each side is cosecants. So I have some hope that we're going to be able to just solve this without any further identities. Let's see how far this goes. Now I need to clean up everything so that there's a 0 on one side and I can get myself towards some factoring. And this is going to turn into 0 equals 2 cosecant squared minus 5 cosecant plus 2. Okay, I just combined some like terms on the right side. And now we're going to try some factoring. I'm going to skip most of the U substitution, big X type stuff. You can do the factoring on your own if you want to take a little time to see how this works out. Or you can guess, right? There's also the guessing method when numbers are small. That works fine. And so here's what I have. These two factors multiplied together equals 0. So we're going to use the factor theorem here and say, well, that means 2 cosecant minus 1 equals 0, which means cosecant equals 1/2. And then on the other side, this one's easier to solve. I'm just going to say cosecant equals 2. Well, cosecants are fine and all, but I would actually like to move this a little bit towards sine functions. I'm more familiar with those on the unit circle. So this is going to say sine equals 2 and sine of phi equals 1/2. Now, one of these things does not exist on the unit circle, right? This guy right here over on the left, nope, that is a DNE, right? There is no angle where the sine of that angle equals 2. But sine of an angle equals 1/2, well, that's fine. So I'm going to draw a little unit circle here. And if I imagine where the y value is equal to 1/2, it's over here and over here. Okay, so those are my locations where sine of phi equals 1/2. So here's my answers. It's going to be, let's see, it's going to be pi over 6. And it's going to be, what is that, 5 pi over 6. Okay, those are my two answers. Now, one more thing. This problem did ask us, if you remember, for all angles phi. That means 0 to 2 pi is not enough. I need to go beyond 0 to 2 pi and think of all the infinite angles plus or minus. So what we're really talking about here is those two angles plus 2 pi k, where k can be any integer. So what you want to write down in this answer box here, because the computer's not quite going to understand what I wrote just there, you're going to want to write it like this. Pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k, where k can be any number 0 to 1, 0 to infinity, or negative numbers for that matter. As long as it's an integer, that'll be fine. Okay, so there are your solutions.